G'day, Michael here. I've been trying to get better and better performance out of this Tevo, and a couple of areas of improvements have already happened, and that is, well, the biggest one that I've made is getting about 300mm of travel out of the Y-axis. If I simply could get the the Y-axis motor off the rail and put it behind, I'd get nearly 400mm of travel. But that of course gives a problem with the print platform. As in this one here is 300 by 400, this slab of aluminium, and at the moment I can kind of use about 280mm by 390, so that's about my limit at the moment. But in any case, that's a lot larger than the 240 by 390 I had a little while ago. Right, and I'm trying to get parts obviously to go through this thing pretty quickly. I've got currently a 0.8mm tip in on the machine. Now I was easily able to hit a speed which would exceed the melt speed that the hot end could deliver, and I couldn't understand. I put a volcano hot end on this thing, but I used the Tevo's own element because the obviously the little connectors and so forth already set up on the Tevo's element. And I didn't think the Tevo's element would be that different to the one that was in the volcano. Anyhow, what I did was I changed. You can see I've jemmied up with a bit of soldering because I'm waiting for the JST connectors to turn up. The JST connectors are these things. Okay, so I've soldered this up to make that all happen. Anyhow, I used resistance measurement to work out the wattage, and I wasn't able to get a really stable measurement of the ohms of the resistance on both elements. But one was showing 4 ohms, that's the unit that's in the machine now, and the other one was showing around 15-16 ohms. So a rough rule of thumb, you've got ohms as volts divided by amps, so it's voltage divided by current in amps, and working backwards, then by that I worked out the wattage. Now that meant that the element that came with the Tevo was around 10 watts, and this one here is about 35 to 40 watts. Yeah, they're not labelled because I've just calculated from the resistance. Now, this is the speed that I was running the other element at. Now let's see what we can get this girl to do. These are large prints. A lot of people wind up the speed on their printers so they get ridiculously high speeds, but on little prints the stepper motor arrangement does not accelerate to full speed. Because this is a fairly large part, what is it, about 230 or 40 by about 90, and the paths are diagonal, if I crank up that speed factor, it will actually genuinely hit the speed that I asked for. Currently I think it's doing about 30mm a second, and I'll crank up the speed factor. Let's just have a look at the display. Okay, now up we go. Let's pump it out to, let's try about 200%. It'll take a while to clear the buffer. You'll notice it pick up speed shortly. Now currently you can see the spool is moving pretty quickly anyway. That's kind of the dead giveaway of the the melt speed of the tip is how fast the spool is. You could still probably get about 1 RPM at this speed. But as this thing picks up, here we go, it's starting to pick up. Just used up the buffer now. Give it a couple of passes so it'll get to full speed. Now let's see what this thing does. As you can see, this is a very full spool. That's a 1 kilo spool. Certainly won't take long to do a full turn at that rate. Okay, the print is still nice and glossy, so let's bump the speed up again. Now, just wound it out to 260 degrees, 260%. Now you can see there is a bit of a surface change here, so we're getting close to the speed limit of the material before we start having interlayer adhesion problems. It's a bit hard to see with the lighting. Just now I'm sort of pushing. This is probably getting close to the limit of what the material itself can stand. You can see there's a bit of a difference in the surface. It's not quite so glossy. but it still seems to be melting in at the ends quite nicely. Let's have a look at that. Still a nice melt in, so it's probably still quite adequate for interlayer adhesion. So now, we had some binding issues there, so we've actually hit the speed limit of the material's own behaviour by the look of it. Let's just see what the temperature's doing. The element's having no trouble holding the temperature. So now we've seen that the limit, that's 262% feed rate, and it's still holding temperature nicely at that. So we haven't exceeded the melt speed of the tip, but we have exceeded, you know, how quickly the material itself is melting going through the machine. So basically I've just lost that part, so I'll stop this and redo it. But it looks like 200% of the speed was quite an acceptable thing, but the 266%, getting that first layer down might be a bit tricky. So it probably means that if I drop down that first layer speed to maybe even 30% slower in the design, but the rest of the print I might be able to leave the speed up. So you can see there's a failure there, but we've seen our limit there on how fast that material can go through. Also, funny enough, larger tips don't melt as thoroughly at high speed as the smaller tips, because obviously something going through a smaller tip is exposed to the metal more fully. So that being said, we're still definitely getting way more through this this tip than you'd ever get through a smaller tip. So it's a bit of a, can't really compare them directly. You can see it's really going through material at that rate. Let's go zoom out a bit more. Well, I guess that's it. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.